The demonstration of lung nodule detection and classification. Let's just get started with a nodule image. We have taken this image from Tata Cancer Research website. Now if you look closely at this image, this is a nodule area as per the truth data. However, by looking at this image, it's quite difficult to locate the nodules. Lung nodule detection is quite challenging. Now what we do is basically we need to smooth out this area and need to locate all probable nodule candidates. So we are going to first smoothen it up. The smoothing is performed using median filter. Now after smoothing, you can see those areas, this has become more prominent. Now we use the Gaussian blurring to make this changes, this sharpness decrease a bit, so that the nodule, the other parts other than the nodules appears blur, and then we average the blurring and followed by a thresholding. Once we perform thresholding in this, we see several nodule candidates. Now all of these candidates has the possibility to become nodule. Now how do you detect which is nodule? Now for that we go for a morphology. Once we go for the morphology, it marks a bounding box across each of these candidate nodules. Now for any further detection, we need to train the system with what we consider to be nodule and what we don't consider to be nodule. So from a truth image, we need to train it first. So once we click on the training, it shows the exact area which is appeared over here, and we need to train it with the class. So this is the actual image as it appears, and it's over the area, so it makes it quite easier for the trainer, the person or the person who is training this. Now this is obviously not nodule, a normal area, so we just say it's normal. Now this one, this is obviously normal area, we set it as normal. This is obviously the normal area, we set it as normal. This is obviously a normal area, again we set it as normal. Now this is where exactly the nodule is as far as the truth data. So we are going to say that this is abnormal. Again it traces this, which we find to be normal, and this one is obviously normal. This is also normal, this is also normal. This is also normal. So once you have done the training, it has marked all the areas. You've been able to successfully mark all the areas. Now once you give any images, say for instance we have converted the image into database image. Let's give one more image as input. Let's just smoothen it up, blur it, average it, threshold, morphology. Now we need to test it. Now for testing, we have used two classification: ANN nodule classification, SVM classification. Let's go with ANN nodule classification. So all the training data, it extracts the texture feature. We have considered the fractal texture feature over here, and we have built a neural network based on the fractal feature. As we can see that there are totally 30 fractal features. So from here we can see that there are totally 30 fractal features and 2 output layers. We have considered 100 hidden layers. If we look at the performance, the training and the validation were not successful. Now that's because there are too many candidates which have been wrongly detected. Now let's just try to classify using SVM. So SVM is a two-class classifier, therefore has got a better possibility of detecting the nodules properly. So if we combine the SVM and neural network, we get a better approximation of the area which we consider to be nodules. Now let's just select one more image. So let's just select one more image where the nodules is much more prominent. Let's select this specific image over here. Let's just do the pre-processing, thresholding, morphology. So morphology has again marked all the probable nodule candidate. Now our proposed solution should be able to identify this area as the nodule. Now let's go with ANN classification. Ideally, once you create the neural network, it should not be training, but for the demo purpose, I have repeated the training. Now look carefully that because in this one the nodules is much more prominent, neural network has been able to successfully identify this area as the nodule area. Let's go with support vector machine then. So support vector machine divides the texture into two groups, normal and abnormal, and the support vector machine has also been able to trace it successfully. Now let's just combine the support vector machine and neural network. Now if you have only one candidate which has been successfully classified as the nodule by both support vector machine and neural network, that's definitely the nodule area, the nodule candidate that we are talking about. So in this way, we can first take few truth images, get the nodule candidates, train the system with the nodule candidate, and then we can have a texture analysis. You can go with GLCM, you can go with other texture methods, whichever suits you. I have gone with the fractal texture because I have really found it quite efficient in the case of lung nodule detection. So this way you can detect the lung nodule. I hope you enjoyed this demonstration of lung nodule detection. Feel free to use the algorithms. Thanks for watching the video. Thank you.